Hey, this is Patrick Sullivan. Welcome to my shop. This is part 2 of my series on making solid carbide tools. If you haven't seen part 1, I encourage you to do so now. It contains a lot of valuable information about buying, cutting, and shaping carbide. The link is in the description below. In that first video, I made several flat chisels. So far, I'm really thrilled with the way they turned out. They sharpen easily, they take a wonderful edge, and they hold that edge. In this video, I tackle some projects that require a lot more grinding and shaping, and as a result, they beg for some power tools to speed the process. I thought that a 4-inch angle grinder might be a great way to accelerate the cutting and grinding of carbide using a diamond blade. However, for the very small tools that I've been making, I felt I needed a way to make more precise and repeatable cuts. For that, I needed a jig to hold the grinder securely with a surface to stabilize the blank I'm grinding. First, I needed 2 pieces of wood, each with a cutout that closely matched the profile of my grinder body. I drew a circle of the right diameter and then cut out the inside of the circle with a scroll saw, although you could use a saber saw or a coping saw. I will call these pieces the cradle. I cut each of the cradle pieces in half on my table saw. Next, I cut 2 strips of poplar to make a base to support the cradle, which I then notched to capture the cradle pieces. This design allows the pieces to be dry fitted so they can be adjusted for a perfect fit. My grinder body is a somewhat irregular shape with a little taper, so some tuning was necessary. After I trimmed the cradle pieces to fit the lumps and bumps of my grinder, I glued the bottom halves into the base supports. When the glue was dry, I drilled 1/4-inch holes at each corner of the cradle pieces. I then epoxied lengths of 1/4-inch threaded rod into each hole. The top cradle pieces needed to fit onto those threaded rods very accurately. I marked the position of the rods with a pencil and a tri-square, and then drilled matching holes in both upper pieces. Wing nuts will clamp everything together. However, I recessed the space where the wing nuts will sit so that the threaded rods and nuts would be less likely to snag clothing and skin. This is plainly optional and a little frivolous, but it only took a few minutes, and I think it looks better. I assembled the grinder cradle to check alignment. I found that I needed to add a shim to the back part of the cradle to level the blade. I glued on several very thin strips of rubber, which not only leveled the device, but reduced vibration as well. This setup now holds the grinder securely, but next I needed some way to hold a carbide blank against the blade in a stable way. The solution I came up with works, but is not nearly as good as the jig I showed in previous videos for holding steel blanks against my disc sander. I made a small table out of 3 pieces of MDF. The legs straddle the grinder cradle and butt up against it. A simple clamp holds the 2 jig pieces together and allows them to come apart easily and quickly for blade changes. I made the table about the same height above the workbench as the grinder blade. The dimensions of the table are not important, but if I did it again, I would make the table larger with more overhang so that I'd have more options for clamping a wedge to it to guide the angle of the blank against the spinning blade. I then cut some wedges of wood at predefined angles to guide my hand in setting the correct bevel angle and to help flatten one side of the round blank. When you start with round carbide blanks, you need some method to keep the blank from rotating. First, I tried gluing a thin strip of wood to the blank with CA glue. This worked, but I subsequently found that using my needle-nosed locking pliers was more convenient and worked even better. The face of the jaws is flat and rests securely on the wedge. I get good repeatability from this. Grinding the carbide in this fashion can generate a lot of heat if you hold the piece against the diamond blade for more than about 10 seconds. In this close-up, you can see the incandescent red color. Now, carbide tolerates heat up to about 1500 degrees Fahrenheit, but I suspect it would be easy to exceed that limit. Moreover, I don't think that high heat is good for the diamond wheels. Cool the blank and the wheel by dipping the blank in water frequently or by applying water with a Q-tip or a dropper. Water also reduces the amount of fine dust that becomes airborne. I like having the grinder wheel parallel to the workbench surface with a tool blank directly over it. It provides good visibility, and it also means that water drops will sit on the top of the blank to cool the metal, and when they do run off, they fall onto the cutting surface, where they do some good rather than running down onto the workbench. Next, let's talk about blades for the grinder. I bought a general-purpose diamond blade from my local hardware store, and you will see this blade in some parts of this video. I chose it largely because it was inexpensive and readily available. However, the blade turned out to be far from ideal for this task. It has a very coarse grit, leaves a rough surface, and yet it doesn't cut very fast. But its worst feature is that the diamond plating on the side of the blade is much too narrow to be convenient. I made 2 tools with this blade, but it was so disappointing that I ordered several new blades online through Amazon. The ones I got are called diamond-coated flat lap discs. They're 100 millimeters in diameter, which is just under 4 inches, and they have a 5/8 inch hole in the center, so they fit on a standard angle grinder. As you can see, the price is very reasonable. I purchased blades from both Excel and Joiner, and so far I have not seen much difference. These blades are much more satisfying to use. For one thing, the diamond coating covers most of the disc instead of just the edge. In addition, they come in a wide variety of grit sizes. I bought 240, 400, and 800 grit blades just to see what the difference was. The 240 grit blade cuts much, much faster than my hardware store blade, and it has less vibration. Here is a 1/8 inch round blank that I milled into a low-angle paring chisel in no time at all. In fact, the danger is that for tools as small as this, the 240 grit blade may cut a little too fast for good control. The surface it leaves is very good, and you can polish up these bevels on a fine diamond stone in just a few minutes. I tried grinding away the bevel on a much larger and thicker rectangular carbide blank that measures well over 1/4 inch wide and almost 1/4 inch thick. This involves removing about 10 times as much carbide as I did on the 1/8 inch round blanks. I removed this large amount of carbide in approximately 2.5 minutes. If I did this manually, it would easily take more than an hour. I removed the last 10% or so of the bevel with the 400 grit blade. Surprisingly, it seems to cut almost as fast as the 240 grit. If you are making small chisels and carving tools, I think this one blade would serve most of your needs. It leaves a clean, smooth surface, although you can see the mill marks. Finally, I removed a thin layer of carbide with the 800 grit wheel. It cuts much faster than I expected, but best of all, my new chisel came away extremely sharp, actually ready to use, before any touch-up on finer stones. I then beveled the upper edges of the chisel on the 800 grit wheel. This took no time at all. In this greatly magnified view, the diamond abrasive marks from the 800 grit wheel are visible on the face of the carbide, but the surface feels smooth. Polishing took just a few strokes on my extra fine diamond stone. With these abrasive blades, you can quickly grind just about any convex shape you want, and it won't take you very long. With very small blades, the challenge will be to present the blank to the spinning abrasive at consistent and accurate angles to achieve exactly the shape you desire. The solution will often be to cut small wooden support pieces that will guide and control the blank. Guide blocks may be secured with a dab of hot melt glue or a small clamp. In the next video, I will show how I shaped a carving gouge in Carbide. This tool has primarily curved surfaces and requires some special techniques and tools. Check my other videos for additional tips and tricks, and please subscribe if you want to see more projects of this kind. Thanks for watching.